Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss local field at an atom. Let's begin. The resultant field responsible for polarizing individual molecules or atoms of solids, that solid is nothing but dielectrics, is called the local field. Let us consider a dielectric which is placed in between the charged parallel plate capacitor. One is positively charged, another one is negatively charged. Therefore, an external electric field is created in between the charged parallel plate capacitor. Let that external electric field is inert. And at the two ends of that of dielectric, there will be negative charge. Induced. At that end, positive charge is induced. Inside that of dielectric, again an electric field created. That electric field from positive to negative, that is EP. Electric field due to polarization. If we take an atom inside that of dielectrics and assume a spherical surface around that of atom, and that atom is present at the center of that of spherical surface. Due to the process of induction at the surface, we assume that at that end negative charges are induced, on that end positive charges are induced. Due to this induction of charge, again there will be an electric field, and that electric field is nothing but ES. That electric field, that is ES. Look at that figure. Inside that of spherical surface, there will be a huge number of atoms present, and we know when we apply an external electric field to that of dielectrics and atoms inside that of dielectrics, an induced dipole moment is created, and due to that induced dipole moment inside that of atom, it provides a new kind of electric field, and that electric field is known as EM. That electric field is EM. Okay. So, here according to the definition of local field at an atom, that is the resultant field responsible for polarizing individual molecules or atoms of that of solids. Therefore, the net field that is nothing but local field. Experienced by the atom is given by E local is equal to E naught plus E p plus E s plus E m. E local due to these 4 electric fields. Where E naught, that is the field between two plates of capacitor without dielectric, and its value E naught is equal to sigma f divided by epsilon naught. Equation number 2, where sigma f, that is the surface charge density of the plates on that of capacitor, surface charge density of capacitor plates. Plus sigma f, here minus sigma f. Next, EP, EP, that is the field at the center of that spherical surface. Let us see. due to polarized charges on plane surfaces of dielectric. And that value EP is equal to sigma p divided by epsilon naught, whereas sigma p the charge density, surface charge density due to polarized charges next ES that is the field at sea, and that field is created due to polarized charges on the surface of cavity and that value of EC is to be calculated. We have to calculate what is the value of ES and the field at sea due to polarized charges on the surface of that cavity. Next, EM the field at sea due to all the dipoles of the atoms inside the spherical cavity and the value of EM here will be 0, because non-polar isotropic dielectric, the net induced dipole moment will be 0. Therefore, the electric field contribution again 0. Equation number, here equation number 4, here equation number 5. We put these values in equation number 1. Therefore, equation 1 becomes E local is equal to E naught sigma f by epsilon naught, sigma f by epsilon naught plus E p sigma p by epsilon naught, sigma p by epsilon naught plus ES, that value is to be calculated. So, ES plus EM 0. Therefore, E local is equal to sigma f plus sigma p divided by epsilon naught, this 2 term creates a new electric field term, that is E, plus Es, where that E is nothing but E naught plus Ep, external electric field plus electric field due to polarization, that is the resultant field between the plates. Which is equation number 5. Let we have to calculate what be the value of Es. To calculating the value of Es, we have to choose a small area element on that of surface, small area element on that of surface of that of particular cavity, which makes an solid angle, that angle as d theta at C at an angle theta, with the direction of electric field E. The direction of polarization P will be parallel to that of electric field E. The polarization, the direction of polarization, to show it, that figure can be drawn outside for our clarity. Let's see. Small portion is chosen. It has the solid angle d theta at an angle theta, and the radius as r be the radius. That is the direction of P. Here in the direction of P, that be the direction of surface ds, and its normal component of P is Pn. The only contribution due to its normal component. So, the component which is perpendicular to that of surface ds, we denote it as Pn, and its value is Pn is equal to P cos theta. The component of P which is perpendicular to ds is given as Pn is equal to P cos theta. From that of polarization, polarization is also given as Pn is equal to surface charge divided by area. Surface charge divided by area. Surface charge, let q ds be the surface charge, area ds. Q ds is equal to Pn ds. The value of Pn as p cos theta, or Q dash is equal to p cos theta ds. Another equation, equation number 7. Again we have to calculate the electric field intensity at C due to that surface charge Q dash. The electric field intensity at C due to charge Q dash is given as d es is equal to 1 by 4 pi epsilon naught Q dash divided by r square, or d es is equal to 1 by 4 pi epsilon naught Q dash value as p cos theta ds divided by r square, and the direction of that of field is along that radius. Equation number 8. The field direction, the field intensity is along R. Now we have to resolve that DES into its parallel as well as perpendicular components. Now resolving DE into components parallel and perpendicular, to P. First the parallel component, the component of DES parallel to, that is the component of DES parallel to P is equal to 1 by 4 pi epsilon naught P cos theta ds divided by r square cos theta is equal to 1 by 4 pi epsilon naught P cos theta into cos theta cos square theta ds divided by r square. Again the component of DES which is perpendicular to P, the component of DES which is perpendicular to P, that is 1 by 4 pi epsilon naught P cos theta ds divided by r square sin theta is equal to 1 by 4 pi epsilon naught P sin theta cos theta divided by r square ds. One is parallel component, another one is perpendicular component. Look at that figure. If we choose the perpendicular components, one is up, another one is down due to its symmetry, and these perpendicular components are cancelled out each other, only the contribution is due to the parallel components. Therefore, we see that the perpendicular components will be cancelled due to an equal contribution from another symmetrically situated surface elements. The only contribution, the only components along the direction of P will contribute to the integral of that of entire surface. The integral of equation due to parallel case over entire surface, only contribution due to that of parallel situation. Therefore, ES is equal to closed surface integration 1 by 4 pi epsilon naught P cos square theta ds divided by r square. Equation number 9. Now, the appropriate surface element ds in this case is a ring. So that how this is a ring, ds when integrated over that of entire surface, we can say that is in the construction like ring. Look at that figure, we choose it just like this. and the surface ds is equal to 2 pi r sin theta into r d theta, or ds is equal to 2 pi r square sin theta d theta, equation number 10. Now, that equation number 9 becomes, putting the value of ds here, equation number 9 becomes Es is equal to that surface from the limit 0 to pi 1 by 4 pi epsilon naught p cos square theta divided by r square. In place of ds we substitute 2 pi r square sin theta d theta, that theta limit from 0 to pi throughout that of entire surface, which is equal to 2 pi cancel out, 1 divided by 2 epsilon naught, that is the constant, to that of outside, from 0 to pi p sin theta cos square theta d theta. Let us substitute, we have to substitute here to solve that particular integration. Put x is equal to cos theta, then dx minus sin theta d theta, ultimately that limit change from 1 to minus 1 is equal to minus 1 by 2 epsilon naught, that limit from plus 1 to minus 1 p x square dx is equal to minus 1 by 2 epsilon naught p inside that of integration 1 to minus 1 x square dx minus p divided by 2 epsilon naught, that integral x cube by 3 using the limit 1 to minus 1 minus p by 3 to that of outside, it will be 6 epsilon naught x cube limit from 1 to minus 1 is equal to minus p by 6 epsilon naught using upper limit and the lower limit, minus 1 q minus 1 q minus p divided by 6 epsilon naught minus 1 minus 1 minus 1 minus 1 minus 2 minus minus plus 2 p divided by 6 epsilon naught, 2 6 cancel out, it will be p divided by 3 epsilon naught, that is the value of Es. Equation number 11. Our task was to be calculated the value of Es. Now the value of Es is evaluated. We can put that value of Es in order to gain E local. Therefore, we have E local is equal to E plus Es, or E local is equal to E plus P divided by 3 epsilon naught. Equation number 12, that is the expression for E local. Local field at an atom, and that equation is also known as Lorentz relation. This is the expression local field at an atom and is also called Lorentz relation. Lorentz relation, due to the scientist Lorentz proposed that method in order to find the E local. So, here with the help of this video lecture we understand the concept of local field at an atom, definition of local field, then mathematically we show what are the contributions of various kinds of electric fields towards that of local field. In order to calculate Es, we proceed in this way, and finally integrating that particular integral we get Es, and E local is equal to E plus Es, value of Es as P divided by 3 epsilon naught, and the expression for local field at an atom. Also that equation is known as the Lorentz relation, as the scientist Lorentz suggests that method in order to calculate the local field in an atom. So, with this useful and informative notes, let me wind up this session. Thank you.